I thank you all for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of July 2024. This question is from the section analysis and it is related to the convergence of real series. This question is from the part C, which is a multiple select question. There can be more than one answer. It carries 4.75 marks. The question ID is 704062. I thank my student Venkatesh Sripath from CVR College of Engineering for participating in the discussions of this question. Right. The given question is, let sigma n is equal to 1 to infinity a n be a convergent series of real numbers. Sigma a n is a series of real numbers and it is given to be convergent. For n greater than or equal to 1, define capital A n is equal to a n if a n is greater than 0, 0 a n, capital A n is 0 otherwise. Capital B n is equal to a n if a n is negative, is equal to 0 otherwise. So be careful about capital A n and capital B n. Understand them properly. Which of the following statements are necessarily true? We are given 4 options. Option 1, capital A n tends to 0 and capital B n tends to 0 as n tends to infinity. Option 2, if sigma a n is absolutely convergent, then both sigma capital A n and sigma capital B n are absolutely convergent. Option 3, both sigma capital A n and sigma capital B n are convergent. Option 4, if sigma a n is not absolutely convergent, then both sigma capital A n and sigma capital B n are divergent. Right. Let's now discuss the solution of the problem in detail. We have sigma a n, a convergent series of real numbers. For each n belongs to the set of natural numbers, it is defined capital A n is equal to a n if a n is positive, is equal to 0 otherwise. Capital B n is equal to a n if a n is negative, is equal to 0 otherwise. So let's call upon the option 1. Capital A n tends to 0 and capital B n tends to 0 as n tends to infinity. Is it necessary that this will happen? Let's see. We are given sigma a n is convergent and we have the necessary condition. Because it is convergent, a necessary condition is its nth term must tend to 0 as n tends to infinity. This implies limit n tends to infinity a n is 0, which is a necessary condition. Right. Note that the nth term of capital A n, the nth term of the sequence capital A n, n belongs to n, is either a n or 0. Therefore, limit n tends to infinity of capital A n is either limit n tends to a n, which is equal to 0 by this, or limit n tends to infinity 0, that is 0. See, in any case, limit n tends to infinity of capital A n is 0. It is necessarily happening. Similarly, limit n tends to infinity capital Bn is 0. Therefore, the option 1 is true. Right. We move on to the next option. That is, this is the given hypothesis. We move to the next option. Before going into the next option, we want two results. We claim that capital An plus capital Bn is An. Capital An minus capital Bn is mod An. These are the two results what we want, and we will establish here. For any given n belongs to n, we have the following possibilities for An, small an. 1. An is positive. 2. An is 0. 3. An is negative. Case 1. An is positive. Then by definition, capital An is An and capital Bn is 0 because An is positive. Then An plus Bn is An. An minus Bn is An. Right. So in the first case, this is true. What we have claimed is true. Case 2. An is equal to 0 implies, by definition, capital An is 0, capital Bn is 0, capital An plus capital Bn is 0, capital An minus capital Bn is 0. Agreed. Agreed. Right. In the case of third case, when An is negative, by definition, capital An is 0, capital Bn is An. Right. Then An plus Bn is An and An minus Bn is minus An. Thus, capital An plus capital Bn is An in all the cases. In all the cases, whatever case that is available, An. And capital An minus Bn is, in the first case, An, that is when An is positive. In the second case, 0, that is when An is 0. The third case, it is minus An when An is negative. That means it is equal to mod An. So mod An will serve our purpose, and An minus capital Bn is mod An. So thus we have established our claim. Now solving for capital An and capital Bn from these two equations, we get capital An is equal to An plus mod An whole by 2 and capital Bn is equal to An minus mod An whole by 2. Taking this, we continue. Taking this and we continue in the next slide. So that's what we have. That's what. So call on the option 2. If sigma An is absolutely convergent, then both sigma capital An and sigma capital Bn are also absolutely convergent. Right. So we have hypothesis. Let's look at our hypothesis. Sigma An is convergent. It is given. And in the option 2, you have to take sigma An as absolutely convergent. So sigma An is absolutely convergent. That implies sigma mod An is convergent. Right? Absolute convergence means this only. Agreed. Agreed. Now sigma capital An is equal to 1 by 2 sigma An plus sigma mod An. Why? Because capital An is An plus mod An by 2. We take in the sigma throughout. And the first one is convergent. The second one is also convergent. The sum of two convergent series is convergent. Right. and sigma capital Bn is equal to 1 by 2 into whole into sigma n is equal to 1 to infinity an minus sigma n is equal to 1 to infinity mod an. Both are convergent and the difference is convergent. Therefore, sigma Bn is also a convergent series. So, thus we have achieved sigma capital An and sigma capital Bn are convergent. But what is that we want? We want both sigma capital An and sigma capital Bn are absolutely convergent. So, therefore, we want to show that both these series are absolutely convergent. Note that An, capital An, capital An, capital An is who? It is An when An is greater than 0, is 0 otherwise. Therefore, capital An is greater than or equal to 0. And also, in capital Bn, it is less than or equal to 0 for all n belongs to n. Agreed. Now, sigma n is equal to 1 to infinity mod capital An, sigma mod capital An is equal to sigma An, because mod An, mod capital An is An capital An only. Why? Because capital An is greater than or equal to 0. Therefore, absolute convergence is same as convergence in the case of non-negative terms. Right. This means sigma capital An is absolutely convergence. Agreed. So, what about sigma capital Bn? Is it absolutely convergent? So, let's say put capital Bn is equal to minus Cn. If I put minus Cn, Bn is, capital Bn is less than or equal to 0 for all n belongs to n. So, capital Bn is minus Cn, then where Cn will be greater than or equal to 0. Agreed. Now, sigma capital Bn is convergent. Yes, that's what we have already seen. And that is equal to sigma Bn is minus Cn is convergent. That minus comes out. Minus sigma n is equal to 1 to infinity Cn is convergent. And that will imply sigma n is equal to 1 to infinity Cn is convergent. So, but what is Cn? Now, Cn means mod Bn. Cn means mod Bn. Sigma n is equal to 1 to infinity mod Bn is convergent. That means sigma capital Bn is absolutely convergent. Thus, we have proved both sigma capital An and sigma capital Bn are absolutely convergent. Hence, the option 2 is true. Right. We move on to the next option. We take option 4. This is our hypothesis. This is capital An and capital Bn. And option 4 says if sigma An is not absolutely convergent, then both sigma capital An and sigma capital Bn are divergent. If it is not absolutely convergent, then both of them are divergent. Right. We have sigma An is convergent, is the hypothesis. And it is given sigma An is not absolutely convergent. That means sigma mod An is divergent. Not absolutely convergent means if you take the modulus, absolute values, it will be divergent. It is not convergent, means divergent. So, this will imply sigma capital An is equal to 1 by 2 sigma An plus sigma mod An is divergent. Why? The first one is convergent, the second one is divergent. So, a convergent plus a divergent series is divergent. So, also capital Bn. Sigma capital Bn is equal to 1 by 2 into sigma An minus sigma mod An. One is convergent minus the second one is divergent. The difference of a convergent and a divergent series is divergent. So, thus we got sigma capital An and sigma capital Bn both are divergent when your sigma An is not absolutely convergent. Yes. So option 4 is true. Right. We are left with option 3. Right. For option 3, this is not true in general. So we give a counter example. Consider the series sigma n is equal to 1 to infinity a n, where a n is minus 1 to the power of n minus 1 by n. It's an alternating series. It's an alternating series. It's one of the most well-known examples of. And it is convergent by Leibniz test. It is in fact conditionally convergent. It is convergent, and when you consider their mod absolute values, then it is not absolutely convergent. Now, sigma n is equal to 1 to infinity, capital A n is 1 for the first term, 1 by 1, 1 positive, plus the second term is negative, therefore 0, plus 1 by 3, and plus 0, plus 1 by 5, plus 1 by definition of a n. And capital sigma, capital B n is, the first term is positive, therefore for capital B n it should be 0, minus, and the second term is negative, that is minus 1 by 2, plus 0, minus 1 by 4, plus 0, minus 1 by 6, plus 0, minus so on and so forth by definition of capital B n. Agreed. Now, note that sigma n is equal to 1 to infinity, a n is sigma minus 1 to the power of n minus 1 by n is not absolutely convergent, because it is conditionally convergent. It is not absolutely convergent. When it is not absolutely convergent, we have already seen in option 4, that is a true statement. That is, in option 4 we have seen if sigma a n is not absolutely convergent, then both sigma capital A n and capital B n, sigma capital B n, are divergent. So, using this, by option 4, both sigma capital A n and sigma capital B n are divergent. When you do not want to use the truth of option 4, you see sigma capital A n and sigma capital B n and use the tests of convergence of the series. In this case, you can use the limit comparison test, and both of them are divergent. So you can show even by that also. So that's therefore option 3 is not true. Why option 3 is not true? Sigma capital A n and sigma capital B n are divergent, but option 3 asserts that both of them are convergent. It is opposite to that. So the option 3 is not true. Now, combining all the options, the answer to this question is options 1, 2 and 4. And that is the detailed discussion of the solution of the given problem from the section analysis, which is related to the convergence of series. In my opinion, it is definitely a very difficult question. In the examination, while writing the examination, I think it will be a tough question there. Anyway, I am sure that you have understood the solution of this problem. I thank all my viewers for watching my videos. Please like them and share my videos with your friends and colleagues. Please subscribe my channel if you are not already subscribed. I wish you all the best. Thank you.